Hey everyone, let's try solving together some systems of equations, and this time I have selected some more complicated systems. Now, what makes them more complicated is simply the fact that we'll need to simplify, to do a little bit of work before starting to solve them, and simplify the equations, bring them to the form ax plus by equals c, where a, b, and c are simply integers, so no decimals, no fractions. So we're going to start off with systems of equations that have decimal coefficients. So the way we approach this is by inspecting each equation to determine the number of decimals in each coefficient. And then we have to convert the decimal coefficients into integers by multiplying each equation by 10 if the smallest coefficient has one number after the decimal. We multiply by 100 if the smallest coefficient has two numbers after the decimal, just like in here. And we multiply by 1,000 if the smallest coefficient has three numbers after the decimal. So let's get started with the first system. Now, the rest of the steps will be the same, just like in any other question we have done so far. So as you can see in here, we have one decimal place for every number or coefficient we see in the equation, which means that both equations will benefit from being multiplied by 10. So 10 will multiply every term in the first equation. Don't forget the right side as well. And this 10 will multiply every term in the second equation. And our equations are going to start looking different. So 0.2 times 10 is 2x. And then 0.3 times 10 with a negative, that would be minus 3y here. And then here we're going to have negative 0.1 times 10 equals negative 1. So next we have 0.5 times 10. That would make 5x minus 0.4 times 10. That's a 4y. And lastly, we have 10 times 0.8, and that makes it equal to 8. So here is our system. Take a look at it and think, what method do you want to use? We can use either substitution or elimination. And to use substitution, remember that we need to have one of the variables isolated. We prefer to have a variable that has a coefficient of 1 or negative 1, and x has 2, y has negative 3, 5 here, and negative 4. So I will go for elimination instead this time. And because if I chose substitution, I'm going to have to deal with fractions in the rest of the solution. So first we have to make a decision which variable we want to eliminate. I am going to go for x this time, but it doesn't really matter what variable you decide to eliminate, obviously. So if I want to eliminate x, I need them to have either exact same coefficients or opposite coefficients. And I see that these two numbers are not the same, they're different. So they're not the same, they're not opposites, obviously, because they're not the same to start with. So we're going to think, what do we want these numbers to become, or what can we make them into? So as we have discussed in class, when we want to isolate or eliminate one of the variables, we need to make their coefficients same as their lowest common multiple. And the lowest common multiple of numbers 2 and 5 is 10, which means that we're going to try to make number 2 into a 10 and number 5 into a 10. So to make 2 into a 10, you multiply the equations by 5, and to make 5 into 10, you multiply by 2. So what that means is that 5 will multiply every term in the equation now. And we're going to get here 10x minus 15y equals negative 5. And number 2 will multiply every term in the second equation, and that will give 10x minus 8y equals 16. So now that I have achieved to having the coefficient of x the same, exactly the same, I have to think, if I want to eliminate them, do I eliminate by addition or subtraction? So if I add these two equations, I'll get 20x and some more y here equals some number. So that won't help me, but subtraction should. So we're going to have 10x from the first equation, subtracting 10x from the second equation, and then minus 15y from the first, and then minus negative 8y from the second, equals negative 5, and then minus positive 16. So 10x minus 10x, as you can see now, is being eliminated, because 0x, and 15y minus negative 8y is going to make this a plus, and that will make a negative 7y equals negative 21. Now, if you want to see this better and you want to actually show the steps, you can write an extra step, negative 15y plus 8y equals negative 21, and then these two will simplify to 7y. But if you're writing a test, it's not a necessary step unless you want to keep it there. And now you are isolating y from negative 7, divide both sides by it, and then we get that y equals positive 3. Now that we have y equal to 3, so we found the value of y, we can use either equation to solve for x. And I'm going to use the first equation here. It doesn't matter which one, but 2x minus 3y equals negative 1, the first equation in the list. Now we'll have the y value of 3, so we'll multiply or replace y by 3, and okay, we replace y by 3, and now we have 2x minus 9 equals negative 1. 2x is negative 1 plus 9, or 8, which will make x equal to 8 divided by 2, which is 4. So we're going to say that for this system of equations, we want x to be 4 and y to be 3, for both equations to be true, and we're going to say this is going to be the solution. Now, in the same way, we're going to try the next one. I encourage you to try this on your own. So the process is exactly the same, it's just different numbers. So as you can see here, by inspecting the coefficients, I see that the smallest coefficients are in 2 decimal places, and they're all 2 decimal places, which makes it easier for me. I'm going to multiply both by 100. Again, 100 is multiplying every term in the first equation, every term in the second equation as well. So here we go. The first equation now will become 2a minus 3b equals negative 6. Now, similarly, we're going to have 100 here multiplying every term in the second equation. And we have 5a plus 2b equals 23. So now we have to make a decision how we want to solve this. We don't have any coefficient of a variable equal to 1, so substitution may not be the more practical method, so we'll go elimination. And this time I have decided to eliminate the variable b. Now, I see that b has a coefficient negative 3 and 2, so I have to make them the same or opposite. Since they have opposite signs, they will become opposite. The lowest common multiple of negative 3 and 2 is equal to 6. So we're going to have to multiply by 2 the first equation, by 3 the second. So remember that number 2 will multiply into every term. Don't forget this lonely little term here on the right side. It often gets forgotten, so I should make that mistake. If you ever make this mistake, and that's totally fine, please write a note to yourself so that you remember not to make it. When we write things down, we remember them better, most definitely. So multiply 2 by 2a, we get 4a. That's where we get this from, okay? Now, 2 by negative 3b, then we get negative 6b. And then 2 times negative 6, that's negative 12. Now, second equation, 15a, 6b, 3 times 23, 69. So 15a plus 6b equals 69. Now we have 2 happy equations here. ready to eliminate one of the variables. The signs are opposite, which means that simple addition of two equations will help us do that. So eliminate B, and we'll obtain at the bottom here 4A plus 15A, and then minus 6B plus positive 6B, and negative 12 plus 69. So 4A plus 15A, that's a 19A. The B's will simplify. Negative 12 plus 69 would be equal to, so we have a 7 in here and a 5, a 57. Divide both sides by 19. And so happy to see this is an integer, so actually a natural number, so 3. And now we are in search of the coefficient B. I'm going to use the first equation here, why not? And this is 4A minus 6B equals negative 12. Now I know the value of A is 3, so 4 times 3 minus 6B equals negative 12. Now 12 minus 6B equals negative 12. That works out very nicely. So minus 6B equals negative 12 minus 12, or negative 24. And isolate B from negative 6, and we'll get B equal to positive 4. So therefore, we're going to say that the value of A is 3 and the value of B is 4. So the solution in this case will be, and we'll put the numbers in alphabetical order, so 3 and 4. So next, we're going to look into equations with fractions, and for this I'm going to make a new video for it. Please follow along. Bye for now.